A vector is a sequence container that supports random access to its elements. You can think of it like an object-oriented array with a bunch of extra cool features. Vectors are extremely flexible and powerful. Let's take a look. Here I have a working copy of vector.cpp from chapter 10 of the exercise files. The vector template is defined in the vector header file, which is included here on line 3. And here I'm initializing a vector. I declare it with the vector class, and vector is a template class. And so inside the template parameter list, I have an int type. And so vector takes one type and it creates a container of elements of that type. And I name it vi1 and I initialize it with 10 values, 1 through 10. And this initializer list initialization, being able to initialize a vector from an initializer list like this, is actually a new feature in C++ 11. I strongly recommend that you use it. It's much more clear and simple than the old way we had to initialize vectors, which was from a C array. And I'll show you that a little bit later on in this lesson. And so let's go ahead and build and run this. What I'm going to do, just to make this a little more manageable, is I'm going to comment out everything here from line 31 to line 67. And we're just going to look at this top part to begin with. So I'm going to build and run. And so here we initialize the vector and we take the size front and back. And so the size method, it returns the number of elements in the vector. The front returns the actual element at the front, and the back returns the element at the back. So front will return a 1 and back will return a 10. And so here we have size, front, and back in our output. Vectors, like most containers, have iterators. And an iterator is a class that's actually part of the container class itself. It's linked to the container class itself. And there's a type def inside the container class that defines this iterator type. And so the iterator type is actually a class itself. And so you get at that with vector subint like this. And so you use exactly the same declaration as you do for your vector up here. And you follow it with 2 colons and then iterator. And that gets the type def out of the class itself. And so that iterator can be used in most of the same ways that you would use a pointer. And so the begin method returns an iterator at the beginning of the container, and the end method returns an iterator at the end of the container. And so you can use it just like you would a pointer in a for loop. For example, here I'm using auto. I could use this same long declaration here, and it starts at begin, and while IT is less than end, I increment IT, and you see that I get the value just as I would from a pointer in an array with the pointed at operator. And you notice our result down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So most of the time, starting in C++ 11, of course, we have this auto type, and you're not going to want to type all of this every time, especially if you have complicated STL containers of other STL containers. That can get to be really long. So you usually just use auto here, but I wanted to show you that full declaration so that you could see what it looks like. And if I build and run here, you see that we get exactly the same result. You dereference a vector the same way that you would an array. You can use the array subscript operator, or you can use the at method. And you see that both of these return the same thing. This is the 5th element, which is the number 6, because it starts at 0. So 0, 1, 2, 3, 4, 5. So it's the element number 5, which is actually the 6th element. And of course, you can also use a range-based for loop with a vector just like you could an array. And again, that's a C++ 11 feature. And so there's our result from the range-based for loop. So now I'm going to go ahead and comment out some of this. Again, I'm just trying to keep this manageable as we go through this. So I'm commenting out from line 10. We need to keep our declaration here out to line 29. And then I'm going to go ahead and uncomment starting at line 31 And we can go down to the end here, except, yeah, it didn't do what I expected it to do. Excuse me. Except I want to leave this vector of strings part commented because we're going to get to that a little bit later. So I'm commenting out from line 31 to line 61, rather I'm uncommenting, so we can go ahead and use that part. And now when I build and run, you see that we get this output here, and we're including our vector initialization up there. And now we start with an insert beginning at our begin iterator plus 5. And so I'm inserting a 42 there. Now my size is 11, and the element at number 5 here, which is our 6th element, is now 42. And then I can do an erase also based on that iterator plus 5, and I'll erase exactly the same element that I just inserted, and now our size will be 10, and our element at number 5 will be 6 again, and we can see that here. So I've inserted, which made the container larger. Our size was then 11, and then I erased that same one, which then contracted our container and made it a size of 10 again. I can also push an element onto the back, and so when I push an element onto the back, I'm pushing back a 47. Again, now our size is now 11, and the element at the back now, using vi1.back, is now 47. And if we go ahead and print out the entire vector, you see that we now have 11 elements with a 47 at the back. Now, in the days before C++ 11, this is the way that you would initialize a vector. You would first create an array and populate that array, and then initialize the vector with this constructor here that takes 2 pointers, a pointer to the beginning of the array and a pointer to the end of the array. And so I need that size of the array. I could use a size of operator, or since I'm initializing the array anyway, I have a constant for the size of it because that's usually good practice. And there you see that's the vector that we initialized from the array. So I'm commenting out from line 31 to line 60, and I'm just going to uncomment this part down here. And actually that'll generate a warning for this vector that we're not using up here. So I'm going to go ahead and comment that out too. And now we have a vector of strings. So I just wanted to show you that you can use any type in a vector. And this is the string type here. And so I'm going to go ahead and make sure that I include the string type up here. Enough of it is usually included in IOStream that this will probably work just fine without that, but it's a good idea when you're using a string class to include the string header. And so when I build and run here, you see that we have this vector of strings, 1, 2, 3, 4, 5, and it works exactly the same with any type. Your type can be a class, your type can be a fundamental type. Any type you want to use in a vector is going to work exactly the same way. So vectors are a fundamental container type that's very powerful and easy to use. Use it whenever you would otherwise use a C array, but could benefit from some capabilities that vector provides in its object-oriented interface.